Oh no, I slept through the 201 meeting. I'm gonna be in so much trouble. There's gotta be a better way to wake up in the morning. Well, I'm awake now. Wait a minute. It's perfect.
Hey, we're Team 1 and welcome to our Blinds project. The main motivation for our project is accessibility. So what does this mean? We wanted to make our product accessible for those with accessibility needs who can't turn a blind, tilt a blind very easily, and also for those who just have problems getting out of bed, like me. Automation was a really major part of our project. We wanted to make it so that you didn't have to tilt your blinds every time you wanted to use them for accessibility, and so it synchronizes with your alarm, so it helps you get out of bed.
Our stakeholders required that a non-technical individual should be able to install this system without any power tools. In terms of simplicity, it shouldn't take up more than 10 minutes to set this up. The system should consume a minimal amount of power and shouldn't have to be recharged more than once a week. It should also cost less than $25, so people will want to buy it. And it should have a seamless user interface that is so useful that nobody will want to manually open their blinds again.
Our team was able to translate the stakeholder requirements into a simple and intuitive solution. We wanted to make our project with few moving parts and components to improve longevity and keep costs low. By using just a single motor to tilt the blinds, our product will have a long lifetime with daily use. So what does our product do? Our device is able to fully open or fully close the blinds in either direction. An automated DC motor attached to the blind's built-in tilting system rotates to control the tilt. The ESP32 Microcontroller controls the motor, and its wireless functionality allows the user to control the blinds from their smartphone or any other internet-connected device. Once connected, they can control the blinds directly or assign scheduled time and dates for opening and closing.
The ESP32 is a very powerful little microcontroller that works similarly to an Arduino but with Wi-Fi and Bluetooth capabilities built in, making it perfect for Internet of Things implementations. It is the brains of our operation, and it controls and powers all of our components. The ESP32 has 4 methods of communication: access point Wi-Fi, station mode Wi-Fi, Bluetooth low energy, and classic Bluetooth. We chose to use access point Wi-Fi, which means the controller is emitting its own Wi-Fi signal. This allows us to control it directly, as well as set it up in station mode, which can then connect it to a private network after entering credentials. This allows the user to control the blinds from any device on their own network while retaining internet connectivity. Both forms of Bluetooth are viable options, but Wi-Fi allows for much simpler connection and ease of use.
In order to tilt the blinds, there needs to be a device that can rotate the hook that attaches to the blind's tilting system. We designed and 3D printed an arm to connect to this hook, which also connects to a DC motor. The DC motor that we used is the one from the Turn 1 Arduino kits. This motor spins the arm and tilts the blinds open and closed. The mechanism is attached to an accelerometer that tells the motor when to stop.
The user interface for blind control prioritizes simplicity. There are options for directly controlling the blinds, as well as options for scheduling the opening and closing, where you can select individual days along with the time that it will open or close, respectively.
To test the limitations of our device, we compared its performance to manual control in these scenarios. For tilting speed, on average, our blinds can automatically tilt from fully closed in one direction to fully closed in the opposite direction in around 5 seconds. Using our hand to manually turn the tilting stick, it took between 3 and 4 seconds. We deemed this time difference to be negligible. For durability, we ran the device continuously until we noticed problems occurring. The device itself did not break. The only problem we noticed was that our power cables would sometimes become tangled within the blinds. This was due to a design oversight in our prototyping process, which we have since resolved. Finally, we have power consumption. We ran our device continuously until the power supply ran out. The device was able to run for 1 hour. Considering that the device only needs to run for around 5 seconds a few times every day, and that there's idle power drain, the device itself should last a minimum of a month before needing to replace the power source. The device can also be plugged into the wall, which eliminates this power consumption issue.
Future aspirations we have for the project are to combine all components into one simple system. This would further improve the simplicity and accessibility of our design. The device would be easier to install and all components could be controlled through the same web page. We also hope to reduce the size of the system. This would make it less intrusive and compatible with more types of blinds and window frames. Furthermore, we would like to be able to control the up and down function of the blinds. However, we found this challenging as blinds have a very specific raising and lowering system. We could have just uninstalled that system and modified the blinds ourselves. However, we found that this would be impractical for the regular user. This is why we decided to just focus on the tilt for our project, as we found it was more practical and easier to set up.
Alright, here's the first prototype of our design. As you can see, there's this nice frame that we've hung the blinds up so we can test our device. Now, this device is powered by an ESP32 microcontroller. That's the brains of our operation. It's also powered by this remote power bank, which we have smaller versions of for the final model. Now this ESP32 is connected to an H-bridge, and this H-bridge controls the motor attached to the tilting mechanism in the blinds. This is what controls the actual tilt of the blinds, and we're using design already built into the blinds, so it's very economic and very easy to install. These cables going in the back attach to an accelerometer that's attached to one of the slats, so it can tell the angle of the blinds and know when to stop when it's fully forward, flat, or fully backwards. Now, this ESP32 has Wi-Fi capabilities and is currently emitting a Wi-Fi signal, which is connected to my phone. So from my phone, I can control the blinds. Anyone connected to this website can control the blinds from their phone remotely. And this is how we're going to control our device.